This is the Naked Neuroscience podcast with me, Hannah Critchlow, brought to you in association with the Wellcome Trust and in partnership with the British Neuroscience Association. This month, we're absorbing ourselves in addiction. We'll be speaking with someone who's experienced alcoholism and found a creative and social way to help with his and others' recovery. Here's some of his music. And is addiction just a human phenomena? We'll be finding out about mountain goats that get their rocks off nibbling psychedelics, elephants that munch into fermenting fruits, and cheeky monkeys that steal holidaymakers' mojitos. Kicking off the programme, we've all seen headlines about addiction, whether it be to the internet, food or drugs of abuse. There's a lot of research going on in this area, and I visited Dr. Karen Ersch from the Department of Psychiatry, Cambridge University, to find out why she studies addiction and how she thinks science can help destigmatise the issues.
I work in the field of drug addiction, and I like to find out how drugs of abuse turn people's lives upside down. People take cocaine, develop dependence, and behave in a way that they lose their jobs, they make debts, they lose their relationships, families break up because of the drug. And it seems difficult to understand why are they still taking the drugs if the whole world around them falls apart. And for many people in society, they think that these are just bad people, or these are weak people because they just don't manage to get off the drug. And as a scientist, I have an understanding of how the drugs work and how they change the brain in the longer term. And that is very helpful to improve treatment for people who have become addicted to drugs, or how to prevent addiction in people who are at risk.
And we'll be returning to Karen later in the show to find out about some of her research in the area. But first, we've had loads of questions in on the topic of addiction. So to answer a few of them, I spoke with Dr. Amy Milton at Cambridge University. Linseed Larson got in touch to ask, some people seem to get addicted to certain drugs, but others just don't. Why is this?
Many people use drugs of abuse and they never become addicted. So alcohol is a really good example. Most people will go down to the pub, have a few drinks after work, and it's not ever a problem for them. But there are certain populations of people who have vulnerabilities. If you are someone who's quite anxious, you're probably not going to enjoy using some types of drugs. So, for instance, cocaine, which makes people quite paranoid and anxious if they take a lot of it. However, you might find that drugs like alcohol help to relieve some of that anxiety, and so you would be perhaps more likely to become addicted to those drugs. There are some vulnerabilities, like in alcoholism, where very highly heritable. So, for instance, if you have particular genes that mean you don't really feel the effects of a hangover, that means in the early stages of use you can drink more because you're not having the awful hangovers afterwards, and that escalation in use then makes you more likely to become addicted.
Thanks, Amy. And so what proportion of the population suffer from problems with addiction?
It's perhaps surprisingly low for the numbers you would expect. So of the people who abuse cocaine, for instance, actually only 20% of those individuals are classified as being addicted. It seems that the majority can actually have control over their drug use, which, if you think again of the case of alcoholism as sort of a common sense example, most people can control their alcohol intake, but there's a subpopulation of people who then find that they're not able to control their use. But obviously, because alcohol is a legal drug, more people use it in the first place, which means the absolute numbers are greater than you would see for that subpopulation who become addicted to Class A drugs, for instance.
James Harrison has been in touch saying, why do people find stopping or beating an addiction such a hard thing to do?
Well, what happens in addiction is that drugs of abuse, what they're doing is tapping into the reward and motivational system. That exists so that you know to do certain things that are good for you, so to promote you looking for food, to promote you looking for mates, and to make you avoid things that are bad for you. So these are really evolutionary ancient systems. When they control behaviour, they do so in quite an unconscious way. You don't really want to be standing there debating what you should be doing when there's a predator that's about to jump on you. However, when you have a drug of abuse doing this, these mechanisms are then diverted into drug-seeking behaviour. As with all behaviours, repetition breeds habits. And the thing about addiction is that these habits become compulsive, so you lose that brake on behaviour.
Thank you, Dr. Amy Milton from Cambridge University. So we now know some of the science of addiction, but what is it like to live with it? I spoke with Toby Peters, who works with the music charity Squeakygate.
I think mental illness is much on the streets as it is behind closed doors. I think it doesn't take prisoners, basically. And some people self-medicate with drugs and alcohol, and when they get sober or clean, it's quite common people get diagnosed with either depression or bipolar or schizophrenia.
And can you tell us a little bit about your experiences?
I'm a recovering alcoholic. I've been dry and clean now for nearly 6 years, this October actually. I lived on the streets on and off for about 10 years, and I always felt that I was outside looking in. I always felt that I was different. My thought patterns were different from other people. I felt like a hermit in a crowd, and alcohol basically made me comfortable for the period that it affected me until it ran out, and then it wasn't so comfortable, and I sobered up, and I realised that this is what Squeakygate does really, and I'm a great believer that creativity, for some reason, it helps people to sort of connect to other people. I mean, I know people who are complete outcasts. They beg on the streets. You know, people cross the road if they're sitting on the street. They're complete social outcasts. And the sort of work I do is where people can use their artistic skills or their creativity to communicate, break down barriers, and people start actually listening to people with these stereotypical labels. People get acceptance and they listen, and they don't sympathise in a sense of patronisation. They sort of think, hang on a minute, you know, I've got a daughter or a son, or I've got a mother or a father who also suffers from mental illness. So it's sort of like, it's not such as a taboo.
And do you think that Squeakygate are providing a way of bringing people together to feel comfortable and to feel part of a team, but this time a creative team that's creating music?
Yeah, I think it's a really good way of community spirit.
There are my shoes when I sing the blues, and I think I need yellow. See the colours of sin, match a feeling within.
It's a laugh, it's fun, and I think what's really important, it breaks down barriers for the outside world as such to come in and see what people are doing. And we're celebrating that the fact is we're not intimidated by labels. We're not, take us what you see. And I think that's really important. It's very empowering. I think, I am a recovering alcoholic and I will be for the rest of my life. Whatever caused me to drink myself nearly to death is irrelevant now. What's relevant is the fact is I choose not to drink. I have found people who support me and understand me and give me encouragement. And mostly these are people who have either experienced mental health or have experienced alcoholism or addiction, and it gives a way of people to communicate to each other.
So Toby uses creativity to help beat addiction and social isolation. To find out more about recovery, we return to Amy. Quill Childeye got in touch asking what are the success rates for different methods of fighting substance addiction.
It's very difficult to get relapse rates because when people relapse, they often then drop out of medical treatment, so it's difficult to get follow-up. You find that somewhere between 40 and 60% of individuals who've come for treatment are still abstinent 1 year following the addiction or following treatment for the addiction. Of the remaining individuals who have lapsed in that period, then somewhere between 15 and 30% of those haven't become dependent again. So they may have lapsed once, but they've managed to regain control of their drug use to a degree.
And what type of treatments are these then? Are there some treatments that are more successful than others?
There are many different types of treatments, and it's difficult to compare them one against the other because what works for one individual won't necessarily work for another individual. As researchers, we talk about relapse in very, very general terms, but of course every individual who's become addicted has done so in a unique way and for a unique set of reasons. The kinds of treatments that we're really thinking about here are what are sometimes known as substitution therapies, so things like nicotine patches for smokers, methadone for heroin users. There's also cognitive and behavioural therapies, so psychological therapies. Other type of therapies, things like group therapies or family counselling, so the AA 12 Steps programme, that sort of thing. And what works for one person may not work for someone else, and what works for an individual may change at different points in their life as well.
And David Bailey has been in touch, saying, is the mechanism for addiction to drugs the same as being addicted to gambling or, for example, being addicted to computer games?
Well, that's a really timely question because the way in which psychiatric disorders are diagnosed is according to reference to this book, which is called the Diagnostic and Statistical Manual of Mental Disorders. And up until last month, we were using DSM-4, in which gambling was not really considered an addiction. Pathological gambling was considered a mental disorder, but wasn't considered along with addictions. The new version, which came out in May, now classifies gambling along with drugs of abuse in a single category of addiction. So this is really quite a new field, and there's some really good work being done actually here in Cambridge, but also in the States as well, looking at the underlying neurobiological mechanisms of pathological gambling. And the compulsive aspects of the disorders seem to be quite conserved. So that sort of compulsive nature of gambling is thought to rely on the same sort of circuitry as the compulsive nature of drug-seeking and drug-taking behaviour.
And Georgianne Lavery has been in touch saying, do other animals get addicted, or is this just a human kind of trait? So he says, it's said that mountain goats will grind their teeth off to eat a certain kind of lichen off the rocks. Can this be true? Could other species become addicted?
So I have to admit, I'm not an expert on goat addiction, but I did go and look this up. There's a little bit of discrepancy as to whether it's goats or sheep, but there are certainly populations of sheep and or goats who will consume lichens and will grind their teeth down. Or some lichens have psychoactive substances in them, so narcotics and hallucinogens, for instance. So this is sort of quite an unusual example of, I guess, a natural addiction occurring in animals. You also see it actually in some monkeys. So monkeys that are near tourist resorts will go and steal cocktails from the guests and get drunk on those. I think there's also some incidences of elephants consuming overripe, slightly fermenting fruit and becoming drunk. That's not necessarily the same as being addicted, but it's sort of a nice example of drug use in animals. Animals do get addicted, which is useful for those working in addiction, because my lab, for instance, specialises in rodent models of addiction. And rats will use any drugs of abuse that humans will, with the exception of LSD, actually. But I suspect LSD is probably not that pleasant if you don't know what to expect from it. But all other drugs of abuse, heroin, amphetamine, cocaine, alcohol, the rats will use. And interestingly, the population of rats that satisfy the diagnostic criteria for addiction is the same proportion as in human users. So if you allow a population of rats to use cocaine, for instance, about 20% of those animals will work for that cocaine despite adverse consequences, will escalate their use, will lose control over when they use. The other 80% of the animals will use it, but they can take it or leave it, which is really similar to what you see in the humans.
Thanks, Amy Milton from the Department of Psychology at Cambridge University. And if you've got any burning questions about your brain and the nervous system, just email them to neuroscience@thenakedscientists.com. You can tweet us at Naked Neuroscience, or you can post on our Facebook page, and we'll do our best to answer them for you. You're listening to the Naked Neuroscience podcast with me, Hannah Critchlow, brought to you in association with the Wellcome Trust and in partnership with the British Neuroscience Association. Next up, we visit PhD student David Weston from Cambridge for his top neuroscience stories for the month. His first story sticks with the topic of addiction, but this time to painkillers. So it could start out as a simple drug to take away pain after surgery, but prescription painkiller abuse can progress to full-blown opioid addiction. Prescription pill overdoses are estimated to be killing 15,000 Americans each year, and the toll is growing. David reports on a new paper in the area.
Pain is one of the largest research areas in neuroscience at the moment, and it represents a huge portion of both the pharmaceutical industry's interest and also it's a very big challenge for research scientists. So scientists are really interested in exactly how pain works, so how it's signalled and perceived by the brain, and also how we can intervene in the pain process to deliver relief to people who are suffering from things like chronic pain. And one of the most widely used analgesics is morphine, which is an opioid, which means that it's derived from the opium poppy plant. Drugs like morphine act on proteins in the nervous system called opioid receptors. So drugs like morphine bind to these opioid receptors and activate the body's natural pain suppression system. The problem with drugs like morphine, however, is that they've got a really large range of side effects. So you can experience things like tolerance, which is the process by which your body adapts to the morphine, and you need more and more of the drug to actually achieve the same level of pain relief. And also, drugs like morphine are really addictive, which makes them potentially quite dangerous, despite the fact that they're the gold standard for pain relief.
And morphine, isn't that quite chemically similar to heroin?
Yeah, so heroin is actually diamorphine, and that's broken down in the body to morphine itself. So it acts at the same receptors, these opioid receptors.
And so what are scientists doing now to try and find out if they can get a less addictive painkiller?
Yeah, so this is one of the really big things that scientists are looking for at the moment. So they're looking for a drug that can produce the analgesic effects of morphine, so the pain relief, but not produce the phenomenons of tolerance and addiction. And so this has been the aim of a group of scientists from the University of Michigan Medical School in collaboration with some pharmaceutical companies. And they published some exciting data this week in PNAS about several new drugs that they've identified. So these drugs act at the same opioid receptor that morphine works at, but they actually bind in a different place in the protein. And this makes them more selective than other drugs and could result in a reduction of the side effects that you see with drugs like morphine. What makes the drugs particularly useful, though, is that they aren't able to activate the receptor on their own. They actually require the presence of other molecules, like the body's own natural endomorphins or drugs like morphine. So the idea behind their discovery is that they could use this newly identified drug to enhance the natural pain relief system of the body, or perhaps they could use it by administering morphine in much lower doses along with this other compound. And this could really help to reduce the side effects that you see with drugs like morphine.
Promising results for the future there. So the paper that I've chosen for this month is linked to mothers' consumption of alcohol whilst they're pregnant and asking, could it actually harm their unborn children? So fetal alcohol exposure in Europe and the US, it actually affects about 0.2 to 2 in every 1,000 live births. So it's fairly prevalent, and it's where the mother may be exposed herself and the unborn child whilst it's in the womb to high levels of alcohol. And so general practitioners generally recommend that mothers-to-be do not drink any alcohol whilst pregnant.
So the effects of high levels of alcohol during pregnancy are quite well studied, and it causes the neural tube, which is this kind of progenitor structure for the development of the nervous system, not to close properly, and that really affects brain development and spinal cord development.
In the unborn baby, exactly. But what the scientists in this study, which was published this month in British Medical Journal Open, wanted to find out was what could drinking smaller amounts of alcohol, say a glass of wine of an evening, do to your unborn child. And this is the biggest study of its kind. It followed almost 7,000 children, and it looked at the children when they were aged 10 and also kind of logged the mother's self-reports of how much alcohol she consumed. And they were looking at one particular aspect of child development, which ironically was balance. So if I've had more than a tipple or two, my balance is somewhat off kilter and a bit skew-if. So why did the scientists look specifically at balance? Well, the authors argue that balance is an important outcome in brain development, and it underpins many motor movement skills. And children with balance problems, according to the study, also often have problems with low self-esteem, confidence and high levels of anxiety. The scientists are not exactly sure how how these things are actually linked, but apparently there is some kind of link there. Well, the scientists here, they analysed the children at 10 years old, and they looked at their ability to walk on a narrow beam and also to stand on one leg with their eyes closed or open. And then they looked at the relationship between the children's balance and the mother's alcohol consumption. And it seems that mothers that drank moderately, so between 3 and 7 glasses of wine, for example, in a week, their children actually did better at the balance test than mothers who hadn't had any alcohol. So this is quite an unusual finding and possibly counterintuitive as well. And the authors aren't exactly sure what's going on, but they delved deeper into the data and they looked at the socio-economic classes of the mothers and also their educational background. And it seems as though the mothers that were drinking more moderately and more regularly, rather than binge drinking or even abstaining completely, actually had a higher socio-economic class and level of education. I mean, there's limitations to this study, though. We can't infer too much from this study. There's a link there that it is interesting, but we're not exactly sure what's going on, and it would be interesting to study it further. And it would also, I think, be important to continue to study the children later on in life when they're teenagers, when their brains are changing even more with synaptic pruning, and look at their cognitive abilities, so looking at learning and memory skills, maybe impulsivity as well, to see whether drinking has affected that. So this is, a big study in terms of sample size, but one that really asks more questions than would ever affect general practitioners' guidelines.
One of the kind of caveats that I'm thinking of is that the moderate drinking mothers who saw this beneficial effect in the children were from a higher socioeconomic group. So perhaps the benefits from having slightly more money are things like being able to spend more time with your children or send them to sports classes or something that actually improves their balance that way. So it's quite hard to dissociate whether this is necessarily exactly because of the alcohol or because of some other kind of confounding factor.
Exactly, and the authors of the study are really keen to point that out. They're not saying that moderate alcohol drinking causes better balance later on in life. They're just saying that there is a link there, and we're not sure that we understand it all completely.
So sticking with the subject of children, if you've got a brother or sister, you'll probably be very familiar with the arguments that can typically occur in the average household when you're growing up. In fact, many people acknowledge that these kind of spats are a typical part of growing up and that siblings always fight with each other, right? But new research published in Paediatrics this month suggests that the effects of sibling aggression can be more significant than we once thought. So lead author Karina Jenkins Tucker and her colleagues at the University of New Hampshire have been looking at the relationship between sibling aggression and mental health. So using information from some telephone interviews of over 3,500 children under the age of 17, Tucker and her colleagues looked at 3 types of sibling aggression. The first was physical assault, so either without or with a weapon or an injury. Property aggression, so this is behaviours like stealing or breaking a sibling's possessions. And finally, psychological aggression, so behaviours like name-calling or saying mean things. And they found that children who had experienced sibling aggression in the past year were more likely to be mentally distressed than those who didn't experience sibling aggression. And this effect was seen even if the children experienced only one of those 3 types of behaviour. And the effect was compounded, so even greater, in those experiencing 2 or more types of aggression.
And how does this compare to those children that are experiencing this kind of aggression and bullying at school, for example, so outside the family setting?
So this was one of the really key findings. They also performed their kind of analysis with peer aggression as well and found that there was no significant difference in the sort of mental state of children who experienced sibling bullying compared to peer bullying. So the authors suggest in their study that sibling aggression is really underrepresented in scientific literature and that people just don't really consider sibling aggression and rivalry and bullying of this nature to be particularly impactful. Moreover, that it could be even kind of character building within a kind of familial setting. But actually it seems from their evidence that, like peer aggression, sibling aggression can be quite detrimental to the mental state of children.
I mean, they were only looking at 1 year down the line, so it may be that the children that had been particularly bullied by overbearing big brothers or sisters may be more resilient and stronger in character down the line, possibly.
Yeah, so that is one thing. They're only looking at the sort of reports of aggression within a year's time period from when the telephone interviews were taking place. So it would be interesting to see how this kind of relationship is carried forward into the future and into sort of adolescence and sort of early adult years.
So I think I probably need to, at this point, say sorry to my little sister Lucy, and I hope that I didn't cause any lasting damage.
Me and my twin sister are good friends, so I'm assuming there wasn't any negative feeling behind any sibling rivalry there. So,
Thanks, David Weston. And if you want to find out more about any of these stories, the references are all on our website. That's thenakedscientists.com/neuroscience. And closing this month's show, we return to Dr. Karen Ersch from the Department of Psychiatry in Cambridge to find out what's keeping her inspired with her research.
So here in Cambridge, we're quite fortunate to have a strong community in animal models of addiction. So we know quite well how addiction develops thanks to these animal models. And there is now another problem or epidemic developing, and this is the epidemic of obesity. So there's an ongoing discussion whether the model that works to explain addiction can also be applied to people who suffer from obesity, who eat compulsively, and the discussion is still ongoing, and also the scientific evidence is debatable. But what I find striking is that the people who are addicted to illicit drugs, like people who are addicted to cocaine, nobody's ever looked at what they are actually eating. So although their model or their disorder is applied to another disorder, to obesity, very little is known how drug users really eat. And so because I'm doing research in cocaine addiction, I thought I have a closer look of what my participants are eating. And I noticed that there's a widely held misconception about what people with cocaine dependence eat, because in the short term, cocaine has appetite suppressant effects. Some people don't eat when they're on the drug. But when the effects wear out, people do eat. And I noticed that they actually eat a lot of fat, but they are not overweight. So this is quite surprising and remarkable. And so I had a closer look, and I've done a study where I also measured body composition and had a closer look at people's diets. And what it shows is that people with cocaine dependence, that they don't put on weight. And it seems that this might be an effect that cocaine exerts on their metabolism. So it speeds up their metabolism, that they don't put on weight. But when they stop, they do put on weight, and they put on a lot of weight, and they've also developed a habit of eating very fatty food, which obviously makes you put on a lot of fat. And that has an important impact on recovery, because putting on weight when you are trying to get your life back in order is certainly not going to help.
So you found this out of the blue result that links cocaine use with a change in metabolism and almost like a craving for fat.
Well, I'm looking into this now. My research is to understand a person who has developed an addiction, and to understand this person in a more holistic way by looking at their drug use and their compulsive use and their addiction. But their addiction has also implications on what they eat, how healthy they are, on their immune system, on their sleeping patterns, on their well-being. It may look that we are only looking at one little aspect of their life, but in fact, the digger you dig into a problem, the more you understand the bigger picture. And also, hopefully, the easier it will be to help people to really live a more worthwhile life.
Karen Ersch. And to keep you hooked, we'll be publishing an extra special edition tomorrow looking at children who, as young as 4, are becoming so addicted to smartphones and iPads that parents are seeking psychological treatment for them. If you have any comments or questions about this show, please contact Hannah at thenakedscientists.com. You can tweet at Naked Neuroscience, or you can post on the Naked Scientists Facebook page. And you'll find the full transcript for this episode and other Naked Neuroscience episodes on our website. That's thenakedscientists.com/neuroscience. Also on the webpage are information sites for those seeking more information about addiction and its treatment. I'll be back again next month to laugh a lot. We'll be uncovering the brain basis of funny. Why do we love a good joke, and what defines humour? This is the Naked Neuroscience podcast and has been brought to you in association with the Wellcome Trust and in partnership with the British Neuroscience Association. See you next month to open our minds. Bye-bye.